very good morning to all of you, and I am delighted to talk about recent shift in scientific research. So, as was the introduction, I am a PhD student and junior researcher at the Center for Educational Technology, and it is in Tallinn University, Tallinn. So, actually, I'm doing a lot of echo. Can someone switch off the microphone, please? Yeah, thank you. So yes, I'm working at Tallinn University. So first of all, I will start that where is Tallinn and how does the so Tallinn is the capital of Estonia. It is a northern European country. So actually, it looks like something similar that I have posted some photos here. So it is besides the Baltic Sea, and it's in a cold climate, northern hemisphere. And the university looks like something like this. So we are working in Center for Educational Technology, which comes under the School of Digital Technologies. So in this particular talk, I am going to discuss some of the main things about science and how we are talking about scientific temperament. And once we have the scientific temperament, then now we can think about research and what are the research outcomes and what are the recent shift in scientific research. So actually, I'm not going to talk a lot about traditional science and traditional research, but on this particular Science Day, as we are celebrating, so I will try to focus you down according to the research that okay, how research is critical and why India as a country need more and more research, and how can we develop the scientific temperament in the students. As you are primary and secondary and senior secondary students, so probably you must be studying science since a long time. So I will try to give you some glimpse that okay, how can you make your career in science. And science is not about only a particular discipline or studying physics, chemistry, mathematics, or biology, but science is more than a lot more than that. So we will cover all these things in the talk. Okay, so first of all, when we talk about science, then you might have noticed that a lot of formulas and some numbers and biology and these kind of things. But are we thinking the science is just limited to a discipline, or science is more than that? So basically, in schools, what we say about the science that we study physics, chemistry, biology, and then that is the part of the science. So I want to ask, or I want to let you think in this particular dimension that science is more than that as a discipline, or it is like more scientific thinking, or it is a kind of systematic approach, or do we have some observation? So, as I said, that what is science? A discipline, an approach, a system, a subject, or a way of thinking, or all of them. So, science, as we can see some standard definitions of science that are listed here. So the main keywords that you can see here, it's a system first, and it is a kind of body of knowledge. So I'm not going into the philosophy of knowledge, that how what is knowledge and all these of things, but I just want to share this particular opinion and academic background of science, that science is more than a discipline. It's also a kind of enterprise, and it is the application as well. So let's imagine that you are doing practical of the chemistry in the laboratory. So doing the laboratory of chemistry, you follow some standard procedures, right? You follow, let's say, take the beaker, put some chemical, measure down the readings. So this is a systematic approach. So when we talk about any systematic approach of doing anything, it is basically the science. So science is not only the discipline. Science is more than a discipline. Of course, we are studying about physics, chemistry, biology. These are the disciplines. These are the subjects that we study for, I don't know, for maybe 20 years. But more than the science as a discipline, we have the systematic approach, we have the scientific methods. So let's say how we can apply the science in arts. So let's say that someone is interested in painting, and someone wants to analyze the painting. But someone is drawing, someone is painting, that is the arts. But if you want to analyze that painting, if you want to analyze the art, then you can apply the scientific approach, right? So science is more than a discipline. As I mentioned, that is science limited to only PCM? So now think about, they have social science, they have educational science, they have environmental science, they have plant science, life science, medical science, a lot of science. Even in the arts, we can see creative arts, and we can say brain science and all these things. So what is the use of science in, let's say, educational science? You all know, you are a student, so you are in the education, right? So how can we apply the science in education? So as you are students, so you see that your teacher is teaching you every day. At the end of the, let's say, academic year, you appear for some test or some examination, and then your learning is measured on that. So maybe you score, let's say, 50 out of 70. So that is a particular measurement for your learning. So this is also scientific approach, that how can we measure the learning, how can we measure the education, how we can improve the learning, how we can improve the teaching. So applying the science or applying the scientific thinking in any kind of discipline is also a part of science. And I really want each of you to understand that science and having the scientific temperament or having the scientific thinking is more important than just learning the science as a subject. So let's say you learnt about all the physical or natural phenomena in your scientific subjects, but you didn't learn that how these phenomena or how these natural occurrences were studied. You didn't learn the science. So learning about the science, about the physical or the natural phenomena, but how to study them, it's also the science. So let's talk about the Newton's theory. If the Newton has discovered the theory in science, so he didn't discover like out of the blue. He had this scientific temperament. He thought that why this natural phenomena is happening, how this is happening. He put his scientific or critical thinking skills into that phenomena, and then he developed the knowledge which appeared as a scientific subject to you. And then that you are studying now as Newton's theory, right? So this is the use of the scientific thinking. So when we go to the scientific thinking, this is also called the scientific temperament. So when we talk about scientific temperament, what is scientific temperament? So scientific temperament is a kind of open-minded temper, first of all, that you embrace all the kind of opinions, especially in the world when we are overloaded with social media and the information overload. So first of all, it's open-minded temperament. So you have to listen to everyone, you have to understand each other's opinion. This is the first thing in the science. And once you have this open-minded temperament, then the curiosity for the new knowledge, new light, new experiments, and especially following the scientific approach, which is a kind of systematic approach, then we can call that we have the scientific temperament. So let's say that in Ranchi, we have a problem of traffic jam. So traffic jam is a problem. Now, how to solve this problem? So we can apply the scientific temperament into this. We can study that, okay, why the jam is taking place. On which particular time the jam is higher than other times. Is there any particular solution to that? So following this kind of scientific approach to any particular problem or any discipline, and once you have this creative thinking and critical thinking, then we can say that, okay, we have the scientific temperament. And I want to remember you two important quotes in science. So if you want to really develop the scientific temperament, then you must remember two quotes in the scientific temperament domain. First, nothing in science is ever fully settled. Why we are saying this? In science, we learn from our past, we do the experiments, we come with the new results, we learn again. So it's an iterative process. It's not just about one thing. Many people I have seen in many newspapers and social media and everywhere people say, science said this, that virus is like getting stronger. Now we have the vaccine, and vaccine is going to work on this. Vaccine is going to work for this particular virus. But after a few days, new mutants take place, and you say that this vaccine is not going to work. Why? Because the scientific approach or the scientific temperament was applied to a particular problem. The problem evolved over the time. Then we have to investigate that problem again. So that's why we in science we say that nothing in science is ever fully settled, and nothing from the scientific result can go wrong. Yes, we have to learn again, and the result will improve, but nothing is wrong. Okay. And the second code, of course, it learns from itself. Once you have the scientific result, you learn, and again you do the experiment, again you come to the result. So this is the scientific temperament that as you are students, you have to think about that how we can develop the scientific temperament. You can study more about scientific temperament. You can learn from your teachers. You can learn from your experiments. You can think that, okay, there are three main questions that start with how, what, and why. And we have to always ask how this is happening, why this is happening, and what are the solutions or what are the measurements that we can do for this problem. Okay, so once we have gone through the scientific temperament, then we can move on to some general ideas that I want to let you think. First, how does the scientific thinking gets developed? What are the crucial skills? How can a student acquire scientific thinking? Is there any particular training? Is there any particular subject? So I'm not talking about science as a subject. I'm talking about scientific thinking. How can you develop scientific thinking? Is there any training? So let's say that I got course of scientific thinking and I acquired the skills of scientific thinking. No, scientific thinking doesn't come from any course or from any training or any particular subject. Scientific thinking comes when you practice the science, when you learn the science, when you start thinking from the scientific approach, when you start questioning yourself, when you start questioning the phenomena, when you start questioning the happenings around the world. So in that particular line, I want to imagine a scenario. Okay, so imagine you are watching a bird sitting on the tip of a tree. Of course, this is a phenomena. A bird is sitting on the tip of the tree. Now, just imagine in your brain that you are watching a bird who is sitting on the, let's say, tree. Now, when you see this landscape, how do you question yourself? You can question this from an artistic mindset. You can also question this from scientific temperament. You can ask why, how this bird is sitting on the tip of the tree. Can I also do that? Then you realize that there is a concept of force and gravitation that doesn't allow you to sit at the same tip like the bird. So you have to imagine any scenario, then you have to put the scientific temperament. You can also think about this problem from different approach, from different scientific methods, right? Now the second question. So for the rest of the slides, I'm going to talk about these two particular questions. First was how does the scientific thinking gets developed, and the second, how does your body of knowledge gets added to the scientific knowledge. Now, what do I mean with this? Maybe this question sounds retrospective in your brain, but actually it's not. So let's imagine that now we have the mobile phones and internet to everyone. But before mobile phones and internet, there was this basic phone, landline phones. Okay. So how the mobile phones came into the world and how this is particular device is appreciated by everyone. So maybe someone has developed the mobile phone, someone has thought about the internet, and that's why we are using it. So how this particular knowledge came to the existence, and actually this is the science. So how this knowledge gets added to the scientific knowledge. Okay. So there are multiple phenomena. There are, I don't know, uncountable phenomena around us which are still uninvestigated, right? So there are multiple solutions that there are multiple challenges that needs to be solved. And once you solve those challenges from scientific approach, then that particular knowledge is going to be added to the science. Like actually, let's go back to this Newton theory. Once Newton realized the gravitational force, then this gravitational force came to the scientific knowledge. Before Newton, no one knew about the gravitational force because that problem, that phenomena was in the nature, but no one has investigated that knowledge. That's why it was not added to the scientific body. Okay, so this is the second question that I want to elaborate in the rest of the scenario, in the rest of the slides. Okay, so in this particular line, I want to ask you two questions, or I want to think about these two questions. How do your teacher assess your learning in any subject or course? So the basic answer might be continuous assignments, your term test, your final examination, half yearly, and these kind of tests. So do you think that this is the only criteria to measure the learning, or can we investigate this problem and we can develop other assessment skills or other assessment measurement techniques, right? We can do that, because in the literature, in the scientific literature of learning and educational science, this is not the only criteria to assess the learning. So this is also ongoing, this is also an ongoing problem. And as scientific approach, as science students, we can investigate this problem. Second scenario, where the logo in a screen should be placed for the maximum eye catch. You might want multiple TV series and all these things. So you have always seen that logo of any particular brand of any TV channel or whatever, they always place either on the right corner, right top corner, or left top corner. Why? Who find out this? Who found out? Was there any particular region this phenomena was? Of course, it was happening, but someone investigated, right? So these are the problems. There are multiple problems that are still unsolved, and as we are the science students, as we are having the scientific temperament, we need to investigate these kind of problems. Okay, so these are the two lines. And once we think about how the scientific thinking gets developed and how a science knowledge gets to added to the scientific knowledge, we can think about research. So here you can see that on the left side, we already have the existence of knowledge. So this is going as input to your brain, and then you are realizing, you are assessing this information, you are assessing this knowledge, you are building your knowledge on top of this input, and you are finding some other knowledge. So in the brain, in the middle, if you have the scientific approach, if you take the science as an investigation, then you can also produce some output. But right now, what's happening? You are maybe 9th, 10th, 11th, and 12th grade students. So what's happening right now? You are learning PCM, which is getting input to your brain. But when it comes to your brain, it is stuck there. Nothing is going as the output of that input, is it? Maybe you are doing some project demonstrations, but are those project demonstrations really based on some unsolved problems? No. I think as principal members also sharing this, that every year we have the same projects and on. Because the reason is that all the input that is coming to your brain, it is coming as subject. You are not developing the scientific thinking. Once you will develop the scientific thinking, once you will think about some unsolved problems, then you will be able to produce some outputs. And that is more important. Grabbing the knowledge which is already in the world, it's not very much important, because we have the Google. So learning 2 plus 2 equals 4, it's not important anymore. Learning how to add is more important. So learning how and building something on that learning. So creating some content, solving some problems is more important these days. No one cares about how much you can remember. Because for remember, we have the gigabytes, petabytes, and everything. We have multiple servers all around the world. So the more important thing is, can you develop some content? And that content should not be some Instagram post or some Facebook post. That content should be some unsolved problems. And that problem should be solved by some scientific approach, rather than just fighting on the social media and all these things. So as science students, as we have the scientific thinking, we should be focused more and more on creating contents that are the that are the answers for some unsolved problems. Okay, now how can we as students, how can we learn this? The question that I asked in the previous slide, that how can we learn the scientific thinking, and I said that you cannot learn it as a subject, but you can practice it. And to practice the scientific thinking and the science investigation, we have the research. So research in general, the word comes from the French, which is called recherche, and recherche is about the meaning of recherche in French is to go about seeking. So if you want to seek or investigate or find or discover anything, then the recherche is the right word. It's a Middle French word. And that this word recherche is itself derived from the Old French word, which is the combination of re and chercher. And chercher itself means search. Okay, so the basic meaning of research is to search something. So let's come to the definition. So you can see there are multiple definitions of research. Okay, as you can see, some keywords are highlighted here, like detailed and careful study of something, and increase the stock of knowledge, creation of knowledge. So from all of these definitions and highlighted keywords, the most important thing that you can see here, it's a study, careful study, knowledge, methodology, and systematic. So these are the main things. So if you are trying to solve any problem in a systematic manner, any problem, I am using the word any. So any problem in a systematic way, then it's research. So let's say that you have to write an assignment, and to write that assignment, you followed some systematic approach. First, you went to the Google, you typed the query, you searched about the topic. Maybe you find, let's say, 20 good results. Out of these 20 good results, you read them, you synthesized them, and you finally wrote the assignment. So to write the assignment, you followed a systematic approach. First, you searched, then out of those search results, you filtered out of those filtered out results, you read them. Out of those readings, you concluded them, or maybe better word will be synthesize them. Once you synthesize them, then you wrote your assignment. So this following the systematic approach is the research. So you can ask that this was not an unsolved problem. So yes, science is sorry, research is not only about solving the unsolved problem. Research is about anything, detailed and careful study of something. Okay, and when we apply this systematic approach of finding something or studying something in science, then it is called scientific research. So we have the scientific problem, and when we apply systematic approach or we apply the research in more general, then that particular word is called scientific research. Okay. Now, the question is, why are we doing research? Any particular scientific knowledge is there, then why are we doing research? What is the usefulness of doing something in a systematic manner? So as I said, that scientific thinking is all about doing something in a very critical manner, in a very crucial, with very crucial skills. So in the same way, why are we doing research? The same answer is to add knowledge to any kind of discipline or any subject, whether it is arts, science, commerce, or anything. So if you have applied research, then you can add knowledge to the existing knowledge. Then you can also explore and potentially solve the complex unsolved problems, right? So let's go back to our scenarios. First scenario was the word was sitting on the word was on the tip of the tree. Second was about the learning and assessment, and third was the screen area. So a screen area where I talked about that why this logo is fixed on the either on the right top corner or the left top corner. So someone has done the research on this particular problem, and he found out that the best place to stick the logo in a screen is either left top or right top or left top, because the maximum eye gauge is either on the right top or on the left top. It is coming from the brain science research. Okay, so someone researched this problem for a long period, doing some scientific measurement, and then this knowledge came to us, and now we are using it. So every TV channels are putting their logo based on this knowledge. Okay, if you think about this second problem, so the second problem was learning and assessment. This is a really complex problem. So how do we solve this complex problem? We have again the tool research. So if we research this problem, then we can solve this kind of problems. And other on top of this two main points, there are other options, there are other benefits of doing research, like public welfare and systematic manner, to encourage public awareness, and to disapprove lies and support truths. So these are the main objectives of doing research. Now, where can you find the research outcomes? Like, as you study the science, where can you find the scientific knowledge? You go to the books, you contact your teacher, you go to the Google, you go to multiple websites, you find the scientific knowledge. In the same way, where can we find the research outcomes? So if someone is doing some research about any problem in any domain, then where can we find those research outcomes? So for the research outcome, like the scientific knowledge, we have some publishers, which is called publication houses. Like you might have listened, you might have heard about this Springer, Elsevier, IEEE, and some other journals on publication like Bridget and all. Okay, so these are the publication houses who publish the research outcomes. So let's say that you are solving the problem of scenario 3, right? Logo and where to place the logo. So you are investigating this problem as a researcher, and you investigate this problem for, let's say, 2 or 3 years, and once you find some outcome, then you are going to publish this outcome in some publication house, and this publication house will publish some journal or some conference paper, and then this will be published here. So and where to find that article? So whenever the research outcomes are published in a paper, it is called an article. So where do we find research article? So the most common platform where we can find the research outcome is the Google Scholar. Google Scholar is a kind of search engine for researchers. You go to that particular platform, you search the research article, and you will be able to find them. So for the sake of showing, I can show you. I hope you all are able to see my screen. So see, the platform is called scholar.google.com. So this platform looks like this. Whatever the problem that you are looking for, or whatever the article you are looking for, you can search here. Okay. So let's say that I want to talk about gravitation. So you write here gravitation and search. So you see the theory of a space, time, and gravitation. This is the research outcome. Introduction to gravitation. So there are multiple research outcomes you can see. There are multiple filters that you can apply here and everything. Okay. So this is the one of the platforms where you can find the research outcomes. So I suggest all of you to, maybe whenever you are free, you try to use this platform, search about research in your interested area. So let's say if you are interested in electrons and photons, and I don't know so much about these things, so you can go and search here, you can find an article, you can read. And reading a research article is also one of very important skills. Okay, so this is the platform where you can find an article. Okay, now there are so as I showed you that when you search the gravitation, then you might have seen that there are multiple results. Now, how to determine that which particular article is important article, which is useful and which is popular and which is being used by many other researchers? So for that particular purpose, there are four things, or four parameters that you can remember. In my introduction, I think someone has also might be mentioned about citations and references. So number of citation is a very important parameter that defines that how to judge or how to determine the quality of a research paper, and then references and who cited. So for example, I can show you again in just a moment. So in the Google Scholar, when you go to, so let's say if you want to search some researcher. So I am searching a researcher here, let's say Dragan Gajevic. So Dragan Gajevic is a professor. When you search this name, then you will find a profile. So once you go to the profile, so it will show you a professor's profile. His name is Dragan Gajevic. You can see his citations here. It's 20,099, which is a lot. And it determines that this professor or this researcher has a very good reputation in the research. So he has published, I think, more than 1,000 papers, which are listed in here. So whatever the research paper you want to read, you can read from here, and you can also see that citation here. For one paper, let's say that he has published one article called "Let's Not Forget Learning Analytics are about learning." So it is already cited by 834. What does it mean? It means that this particular paper was used by 834 other researchers in this particular area. So this is the importance of uh, this is the importance of citation. Okay. So now I will go to the forms. What is the traditional form of research? So in the traditional form of research, we have the primary research, scientific research, humanities research, artistic research, and historical research. So these are the different kinds of research, basically integrated into the discipline, like old disciplines like arts, science, biology, physics, chemistry, and all these kind of traditional fields of studies. But what is the problem in the scientific or in the traditional research? That in the traditional research, collecting the data about doing the research, I mentioned that it is scientific and systematic manner. So when you follow any systematic manner to investigate any problem, you must have to collect some data. So we do not talk about scientific problem in a very vague manner. We have to always talk about facts and in a form of data. So collecting data in traditional research is complex. Why? Because the phenomena itself is complex, and to understand that phenomena, to collect the data, there is no such particular tool. There is no measurement tool. So for that purpose, there is a problem in scientific research or in traditional research. But for the example, let's say what is going inside the brain of the word watcher, or how is the watcher realizing the landscape, what kind of data can reflect learning progress, or how to collect data about eye gauge. Now think about these problems, and can you define any kind of scientific measurement that can collect the data about these kind of problems? Like for any chemistry problem, you have the beakers, you have the chemicals and everything. But to find out this kind of problems, there is no such scientific measurement techniques. So these are the traditional problems in research. But in the last 2 decades, there is a radical shift in traditional research. Why I am saying this? Because earlier we were doing research for any particular discipline, but now we are doing research combining the disciplines, and this is called interdisciplinary or multiple cross-disciplinary research. So where here what we are doing, we are taking the problem which is coming also from physics and also from natural science, let's say ecology, or we are investigating the problem which is also coming from creative arts and also coming from biology. Now we are that's why we are calling it current research, and it's a shift from the traditional research. So the traditional research was focused on a discipline, but now we are combining multiple disciplines, which is like the current research. And why did we see this shift? Because of the computer science. How computer science helped in this shift? Because earlier we were having the problems in investigating the problem because we were unable to collect the data. because we didn't have any scientific tool to collect or to measure the phenomena. But when computer science came into practice, when computer science came in our life, then we have tons and tons of tools that can be used to collect the data, like faster way, fine grained data, data collection tools, data processing tools. So let's say you are watching a word, then what is happening inside your brain, we didn't know before computer science, but now we have the EEG cap. You place the EEG cap on someone's brain while watching a word sitting on the tip of the tree. Now you can see the EEG spikes. And at the same time, you can observe his facial expression through the video. You can analyze the whole facial features and can combine, and you can make some deduction reasoning. Okay, so the computer science is a key which helps to collect more and more data, and that's why we are now we have shifted from traditional to interdisciplinary research. Okay, and an example of this interdisciplinary research, so let's say initially the education science was one domain which was investigated or researched separately. Computer science was another domain, psychology was another domain. But now what we have done, we have combined all these three domains or all these three disciplines, and the combination of education science and psychology is researched separately in the field of learning science. At the same time, the union of education science and computer science field is researched separately in educational technology, and similarly psychology and computer science in cognitive psychology. And the intersection of all these three fields is technology enhanced learning. So these are the emerging fields that are happening after the combination of multiple disciplines. Similarly, when we talk about technology enhanced learning, then we have the different fields like data science, applying data science, and all these things, metacognition, innovative pedagogies. So I am trying to refer that now as a science student, you are having more and more options to research, and not only in traditional research, but in the multidisciplinary research where multiple disciplines can be combined. So if you have interest in, let's say, arts, still you can do research by applying scientific knowledge and scientific. Let's say you have the interest in nature, in plants, or in, let's say, in some cafe, but still you can combine your scientific thinking and you can investigate that problem. So a recent example in such discipline where I am working is learning analytics. And learning analytics and also specialized area is called multimodal learning analytics. Then this problem of complex solving, it can be investigated from multiple dimensions, and all these dimensions are possible because of the computer science. And this is again how is the multimodal learning analytics, and it's again the combination of multiple fields. And why we are doing this learning analytics, so again we are talking about that how learning is happening, then we are applying this, so you can see the different statistics are applied here. At the same time, we are applying this different philosophy of information like hindsight, insight, and foresight. Okay, so now, yeah, coming to the main point. So if you are a student and if you are really looking for this kind of interdisciplinary research in your graduation or in post-graduation or in PhD, then there are multiple options that I have listed here where you can go. It's United States, Europe, Australia, Japan, India, wherever. In India, we still have very limited multidisciplinary research, like IIT Bombay and Amrita University are doing this kind of learning analytics research, interdisciplinary. But when you go outside, it's the impact is really huge. And for the career, you can go for bachelor's, master's degree. Like I would like to highlight this option, this graduation in learning analytics. A recent graduation course has been launched from Monash University, Australia, where this professor Dragan Gajevic is working, that I showed you in the Google Scholar profile. He's the founder of this particular program. So when you think now in the current form of research where multiple disciplines are involved, options are huge. A lot of options are there, and the possibility as career, it's also amazing. Like you take any edtech companies like Baiju, an Academy, Coursera, Moodle, anything, and any top-notch labs and any European Union research project, they have the options for learning analytics. So I'm not saying that learning analytics is the only option, but I am just highlighting that there is such areas which is coming out of the multiple discipline, the combination of multiple disciplines where you're applying the knowledge to coming from the multiple disciplines. Okay, so now finally to conclude, research is not only a kind of systematic approach, but it is a very, very important skill that as a student or as a human, we should learn, because it gives you the critical thinking of applying a systematic approach or systematic manner to investigate any problem and to create some knowledge. Rather than consuming the knowledge, you can create the knowledge. Okay, and complex problems always you can solve through the research. And as I mentioned that you have the option, you are very young, you have the option of doing the research in multiple disciplines. You can go around the world, you can find some opportunities. So yeah, that's it. If you have any queries or questions, then please feel free to ask me. Any questions, any query? Yeah, please. Yeah, thank you, Mr.